At modern seaports, advanced handling systems efficiently transfer cargo between vessels, storage yards, and trucks, ensuring smooth global logistics operations. MMG introduced an innovative bimodal containerized bulk handling system to export copper concentrate from its Las Bambas operation in Peru. This approach represented a world first, as it combined the use of trucks and rail in a continuous, sealed logistics chain that substantially improved environmental performance and operational efficiency. Instead of adopting conventional railcar unloading systems, MMG designed a container-based solution that keeps the copper concentrate enclosed from the mine site to the final loading point at Matarani port. The process begins at the Las Bambas mine, where trucks arrive with empty bulk containers whose lids have already been removed. Concentrate is loaded directly into each container at dedicated loading stations. Once full, the containers are properly sealed, ensuring that the material remains completely enclosed during the entire transportation route. This sealed condition minimizes dust emissions and prevents product losses, thereby meeting stringent environmental standards while protecting surrounding communities. After loading, trucks commence the first leg of the journey by road, traveling from Las Bambas to a rail transfer station. Here, containers are lifted and placed onto rail cars using standard container handling equipment. Because the containers are conventional in size and design, MMG avoided the need for specialized bulk wagons. This represented a significant economic advantage, since traditional bulk railcar dumping systems typically involve an estimated capital cost of around $50 million United States dollars, in addition to requiring custom rolling stock. Once transferred to rail, the containers travel approximately 286 kilometers to Matarani port on the Peruvian coast. Upon arrival, the rail cars proceed to the transfer building, where the unloading stage takes place. Two rotating spreaders, known commercially as ram revolvers, are deployed. These are mounted on a semi-automatic bridge crane that positions each unit above the rail car. The revolvers automatically remove container lids and then lift the containers to the unloading position. Next, the revolver rotates and tips the concentrate gently into a receiving hopper. The material then moves via conveyor systems to the stockyard or directly to portside loading facilities, depending on shipping schedules. The controlled tipping motion reduces material degradation and dust, while also improving handling accuracy. After discharge, the crane returns the empty container to the rail car so that it can be cycled back inland. Overall, MMG's bimodal logistics chain demonstrates how containerization and standard lifting technology can be combined to create a safer, cleaner, and more economical bulk export system for high-value mineral commodities. Over the last 12 months, more than 1.5 million tons of sugar have been exported using the CRS Rotainer container rotation system. This operation relies on specially designed trailers that carry 25-ton containers directly to the loading area, allowing the product to be transferred straight from trailer to container without intermediate handling. As a result, each loading cycle takes on average only 1 minute and 10 seconds, enabling throughput rates of up to 30,000 tons per day. Furthermore, two Rotainer HD units are deployed at unison, providing a super efficient and ultra-reliable solution. These machines feature electric drives that reduce noise and environmental impact, while also ensuring a safe, clean, and controlled work environment. The connection between trailer and container is fast and simple, allowing operators to maintain smooth and continuous loading operations. The lightweight containers used in this system are locally manufactured, supporting both performance and cost efficiency. Controlled rotation guarantees clean discharge into the vessel with minimal product loss or contamination. Altogether, CRS has developed a well-organized and highly efficient process that sets new benchmarks in containerized bulk sugar export. With fast loading cycles and maximum operational efficiency, CRS truly demonstrates leadership in container rotation technology where performance counts. On the 6th of July 2016, the M/Versus Hollandia arrived at Sheet Harbor, Nova Scotia, to load almost a full cargo of wood chips for export. The operation took place alongside the port's bulk facility, where large stockpiles of processed wood chips were already positioned near the quay. First, mobile loaders and conveyor systems transferred the material from storage areas to the ship's receiving hatches. As the process continued, wood chips were poured in steady streams, gradually filling each hold to the planned loading level. Throughout the operation, the port maintained careful control of loading rates to distribute weight evenly inside the vessel. Additionally, operators monitored the ship's draft and stability after each section was filled, ensuring that the Hollandia could remain safely alongside during changing tidal conditions. Dust suppression measures, including controlled loading speeds and water misting, helped minimize airborne particles and maintain a clean working environment. Meanwhile, barges stationed nearby were also filled with surplus wood chips, maximizing the available storage capacity and keeping product flowing continuously from the stockyard. This allowed the port to handle a higher volume and prevent congestion on the terminal surface. By the end of the operation, the Hollandia held almost its full cargo, marking another efficient bulk handling activity at Sheet Harbor and demonstrating the port's capability in supporting the regional forestry export supply chain. Steel coils are heavy and compact cargoes that require careful handling and precise stowage during loading operations. In this operation, the coils are lifted from the quay by ship cranes and safely lowered onto the vessel's inner bottom. Each coil is positioned with its axis oriented in the longitudinal direction of the ship, meaning the coil faces forward and aft rather than athwart ships. This arrangement improves stability and reduces the risk of shifting during a sea voyage. Before the coils are placed, wooden dunnage is laid transversely to form a protective bedding. This dunnage consists of pine planks, typically 100 to 150 millimeters wide and around 30 millimeters thick, combined with pine wedges. The timber layer prevents direct contact between the steel and the ship's plating, and also distributes the weight evenly across the structure. During stowage, the coils are arranged across the breadth of the vessel, starting from the ship's side and gradually working toward the center. As each base coil is positioned, wedges are inserted under the inboard side to lock the coil securely in place. This simple but effective method greatly reduces movement when the ship rolls or pitches. In addition, further lashings may be applied depending on voyage conditions. Finally, the operation highlights the importance of proper securing of cargo. Incorrect stowage can lead to severe consequences, including structural damage, loss of cargo, and even accidents involving personnel. This description focuses on the modern process of discharging heavy steel coils from a barge and transferring them directly onto specialized RoRo trailers using advanced port cranes. First, the barge is positioned alongside the quay and secured. Then, the port crane operator receives confirmation from ground personnel before lowering the new coil lifting device into position. Because the equipment is engineered with accurate operations, the attachment aligns precisely with each coil's center, ensuring a balanced lift, even with varying coil diameters and weights. Once locked, the crane carefully hoists the coil vertically and swings it ashore under continuous radio communication. The lifting system features 125-ton load capacity, enabling safe handling of the heaviest breakbulk coils transported by barge. Throughout the movement, the system guarantees damage-free handling, eliminating traditional contact points that may cause dents or surface scratches on high-value steel products. On the quay, specialized RoRo coil trailers equipped with crab steering weight in designated transfer lanes. This steering function allows multi-directional maneuvering within narrow port spaces, thereby improving alignment when receiving coils directly from the crane hook. After lowering, the coil is secured with anti-slip materials, and the trailer proceeds toward the temporary storage zone or directly to outbound operations. Importantly, the entire lifting and transfer procedure is performed within a safe working environment, supported by remote-controlled movements, strict operating zones, and enhanced visibility for operators. Consequently, this modern handling system not only increases terminal productivity, but also improves cargo integrity and overall port safety. This video shows lashing work at the ports of Auckland. When a vessel arrives, lashing gangs board the ship, drop bars, remove cones, and secure containers. The job is physical, outdoors, and offers rotation, teamwork, and opportunities to upskill, such as straddle driving. Port handling of bulk materials refers to the systematic unloading of loose cargoes such as cement, clinker, sand, coal, or mineral ores from vessel holds using specialized lifting equipment. In this operation, a grab bucket attached to a harbor crane is deployed to reach deep inside the ship's cargo hold and scoop the bulk material. Once the grab is filled, the crane lifts the load and transfers it toward hoppers or designated storage areas on the quay. At the beginning of the process, the vessel is safely berthed and secured alongside the terminal. Afterwards, operators position the crane directly above the open hatch. Then, the grab bucket is lowered, closed around a volume of material, and raised smoothly to avoid spillage. The material is released either into a receiving hopper connected to a conveyor system or into mobile trucks for direct transport to nearby storage facilities. Furthermore, port handling operations rely on several types of equipment, including crawler cranes, portal cranes, forklifts, and heavy-duty loaders. The purpose of using such equipment is to ensure efficient cargo movement while maintaining safety standards. Because bulk cargo easily generates dust, Dust suppression measures or enclosed handling systems are often adopted, especially when handling cement or other fine powders. In addition, coordination among crane operators, signalmen, and ground personnel is essential to maintain continuous workflow. Finally, port handling activities enable rapid unloading, reduce vessel turnaround time, and support the supply chain of construction materials and industrial raw materials. Consequently, this operation plays a crucial role in international trade and port logistics. The Mantsinen 200R material handler represents a modern solution for efficient and sustainable port and terminal operations. Massive in size, yet remarkably easy to control, this machine is designed to deliver both productivity and agility across different loading and unloading tasks. According to the manufacturer, the Mantsinen 200 offers significant economical and ecological improvements, helping operators reduce energy consumption while increasing overall handling capacity. As a result, it has become a highly reliable option for material handling companies that look for advanced performance combined with lower operating costs. Unlike traditional mobile harbor cranes, the Mantsinen 200R provides far greater versatility in day-to-day operations. Besides bulk materials and general cargo, the machine can also handle full containers, with an impressive capability of stacking up to 5 rows wide and 4 containers high. Because of this flexibility, a single machine can replace several conventional lifting systems, simplifying the logistics process and shortening turnaround times. This advantage is especially valuable in terminals, where space, time, and movement efficiency are essential. The Mantsinen 200R has earned its reputation as a true workhorse in medium-sized ports. Its great lifting capacity and outreach allow operators to work safely and confidently even in demanding conditions. Furthermore, operators benefit from exclusive Mantsinen features, such as the Hyperlift Energy Recovery System, which reduces fuel consumption, and an elevated spacious cabin that gives excellent visibility during loading operations. A built-in load control system also helps ensure safer and more accurate handling of cargo, making each lifting cycle more efficient. Overall, the Mantsinen 200R material handler has become one of the most desired machines among operators. With its combination of power, precision, and ergonomics, it offers a smarter alternative to traditional cranes and sets a new benchmark for container handling performance at modern ports and terminals. Leading retailer Kmart in Australia relies on ISO-loader high-performance transporter straddle carriers to support a broad range of operations at its national distribution centers. These machines are applied for truck loading, container stacking, and order picking, enabling a smooth flow of goods between incoming shipments and regional stores. By stacking up to 3 containers high, the transporter maximizes the available yard space and achieves higher storage densities, which is essential for large retail networks handling continuous volumes. In addition, the straddle carrier offers excellent visibility from the operator's cabin and very precise maneuverability even in confined areas, helping drivers move containers safely near buildings, vehicles, and pedestrian zones. Fast retrieval times also support efficient order picking, so containers holding high-demand products can be quickly located and dispatched. Furthermore, Isoloader designs and manufactures straddle carriers and RTG specifically for small to mid-sized operations where flexibility and cost-effectiveness are highly valued. Their transporter models integrate modern safety features and proven lifting technology to reduce handling risks and protect valuable cargo. Overall, the Isoloader transporter provides an effective container handling solution for distribution environments that require dense storage, rapid container movements, and reliable truck loading performance, making it a practical choice for retailers like Kmart in Australia. In modern port terminals, the straddle carrier plays a key role in handling containers efficiently and safely. In this operation, the machine is used to lift and position a 20-foot container onto a flat flatbed truck. First, the straddle carrier travels to the container storage area and positions itself directly above the selected unit. Its telescopic spreader is then lowered and locked into the container's corner castings. After confirming that the attachment is secure, the operator gently raises the container, ensuring proper clearance during movement. Next, the straddle carrier transports the lifted container across the yard toward the waiting flatbed. Due to its high maneuverability and elevated driving position, the operator maintains excellent visibility, which allows precise alignment even in tight spaces. Once over the truck, the container is slowly lowered onto the flat platform, maintaining accurate placement to facilitate safe transportation. The spreader is then unlocked and lifted away, leaving the container firmly positioned. Throughout the process, the operator communicates with ground personnel to verify correct alignment and to ensure that the working area remains clear. Finally, the truck driver performs a quick inspection and secures the container for road transport. Consequently, the entire loading sequence is completed smoothly, emphasizing safety, precision, and productivity in port logistics. Straddle carriers are designed to lift, transport, and stack containers by literally straddling them, meaning the machine drives over the container and secures it from above. This configuration eliminates the need for separate forklifts for horizontal movement and allows for smooth transitions between storage areas, trucks, and key operations. In practical use, the operator positions the carrier above a 20-foot or 40-foot container, lowers the spreader, and lifts the load under the main frame. Consequently, containers can be stacked several levels high, often up to 4, maximizing the storage capacity of limited yard space. This stacking capability is crucial in large ports, where ground area is expensive and constant vessel traffic demands rapid turnover. Furthermore, by handling internal yard transport, straddle carriers help decouple essential port activities. Gantry cranes can concentrate exclusively on loading and unloading ships, while the carriers shuttle containers to and from storage blocks and truck lanes. This division of tasks increases both vessel productivity and terminal throughput. Modern straddle carriers are also moving toward hybrid and full electric technologies, reducing emissions and noise. Consequently, ports such as Auckland benefit from greener operations while maintaining high performance and reliability in container logistics. The highly organized container handling activities at a modern seaport terminal, where rubber-tired gantry cranes are continuously moving containers from storage blocks onto waiting drayage trucks. This process represents one of the most important links in maritime logistics because it connects maritime transport with inland transportation by road. Each shift, crane operators can complete an average of 100 to 120 container moves, depending on container flow, traffic conditions in the stacking lanes, and vessel schedules. To begin with, inbound containers discharged from container vessels are temporarily stored inside allocated stacking blocks. These blocks are usually organized by destination, shipping line, cargo type, or custom status in order to speed up the future collection process. The rubber-tired gantry crane, commonly called RTG or sometimes transtainer, is the principal piece of equipment operating within these yard blocks. Because it straddles multiple traffic lanes, the crane is capable of accessing several stacks without the need for fixed rail infrastructure. Once a truck arrives at the designated pickup lane, the driver positions his vehicle precisely under the RTG, following the ground markings and traffic signals. The crane operator receives the container number through the terminal operating system, and then lowers the spreader to lock onto the container. After securing the load, the operator hoists the container and travels horizontally to the truck lane, carefully aligning the spreader above the truck chassis before lowering the container into place. In the ports of Antwerp, the process can be observed with multiple trucks lining up simultaneously, creating a continuous flow of outbound moves. The ability of the RTG to work 4-high means that it can handle stacked containers up to 4 units vertically, therefore maximizing yard capacity in areas where land is expensive or limited. Because of this, the crane provides significant mobility and adaptability for different yard configurations. Traditionally, most RTGs are powered by large diesel generator sets ranging from 100 to 600 kilowatts. Although highly flexible, diesel RTGs are known for their fuel consumption, often burning up to 10 gallons of diesel per hour, which contributes to local emissions in port areas. However, to improve air quality, several ports have begun introducing electric RTGs. The first electrified units were deployed in China in 2008, and ports in North America, such as Long Beach, are also converting diesel units to electric systems. In addition to transfer operations at port yards, rubber-tired gantry cranes are also widely used outside the intermodal sector, including for erecting unbalanced components, positioning pipelines, or supporting bridge construction, demonstrating their high versatility. Finally, to further increase efficiency, automation solutions are being increasingly integrated into RTG operations. Automated gate systems, automated container tracking tools, and partially automated stacking cranes are helping terminals reduce human involvement in repetitive tasks while improving safety and productivity. As seen in the video, The continuous movement of containers onto trucks highlights the critical role of RTG cranes in maintaining cargo flow at the world's busiest ports.